Hi Math, I'm Andy. Today we're going to look at a system of equations, which means that you have two or more equations that contain the same variables. I see that there's an x and a y in both of my equations, so I know I have a system. Now if I were to graph this, what I'm looking for is where those lines intersect. I say where x marks the spot. Now that intersection is going to be some coordinates, some x and some y. What we're looking for is what is the x and y values that make both of these equations true. Now there are a couple of techniques that we can use to solve a system algebraically. I'm going to use the technique known as elimination. Elimination is where we can add or subtract the two equations together and one of your variables will become eliminated. So it's kind of like we combine like terms and hope to get a 0. Now when I look at this, if I combine 3x and 2x, I don't get 0, I get 5x. And if I subtract them, I get 1x. If I combine negative 3y and positive y, I don't get 0 in any way. And so I need to do some algebraic manipulation. What I can do, or what I'm going to try to do, is get the coefficients to be the same number but opposites, so I can add these equations together. Now I notice that 3 and 2 are both positive, so I could multiply this by 2 to make a 6 and times this by negative 3 to make a negative 6. But one of the strategies you look for elimination is you look for coefficients that are already opposites. I notice that my y value is negative in the top equation and positive in the bottom. So that's kind of a good indicator to say, hey, let's eliminate the y. Now, they aren't the same. This is 1y and this is negative 3y. So what I'm going to do is kind of like a arithmetic trick. I'm going to take everything in this equation and I'm going to times it by 3. That's not going to change the values of the equation itself, but it's going to change the structure of the terms. I'm going to take 3 and multiply it by 2. Now, the top equation didn't change. It's still 3x minus 3y equals 33, but the bottom equation has now been manipulated. 3 times 2 is 6x. 3 times y is now 3y. And 19 times 3 is 57. So I took the bottom equation and I times it by 3, keeping it the same. These are the same lines. They just look a little better for our elimination because now you'll notice my y values are the same but opposites. They're going to cancel each other out when I add. So I'm now going to add these equations vertically, combining like terms. 6x plus 3x is 9x. Negative 3y plus y is 0y. And so 0y is kind of like nothing. It fades away. And 57 plus 33, well, 7 plus 3 is 10. 5 plus 3 plus 1 is 9. So by adding these together, this says 9x equals 90, and I can divide by 9 on both sides, and I get that x equals 10. So like I said, I'm looking for the coordinate that these lines intersect, and I know that they intersect when x is equal to 10. But I still need my y value. So I'm going to go back to one of my questions, and I'm going to use the substitution property to replace the letter x with the value 10. Now either equation will do, you'll get the same answer, but I just noticed the second equation here, y is by itself with no negative 3, and so I'm just going to use the second equation. This second equation is 2x plus y equals 19, but now instead of a 2x, x is 10. So this is 2 times 10 plus y equals 19, because I've taken this value of x and I substituted it in. Now I'm just going to solve for the y value. 2 times 10 is 20. 20 plus y equals 19. And I'm just going to subtract 20 on both sides, and I get y is equal to negative 1. And so when x is 10, y is negative 1, and this is the solution to our system. And you could go back and check it as well. 3 times 10 is 30. 3 times negative 1 is negative 3, and 30 minus negative 3 is also 33. So 10 negative 1 solves both equations. It is our solution to the system.